So number 27 says, Shirin saves the same amount of money each month. This table shows how his savings account balance is changing. So the same amount each month means that this is a constant rate, or this is a slope. Okay, so that indicates a constant rate. So it says, how much money does Shirin save each month? How could you use this concept of slope to determine? Well, this is essentially slope. So if I work out the slope, the change in y, in this case it's going to be plus $135 over the change in months, which is 3 months. Okay, we can work out the slope is equal to the change in y over the change in x, or positive $135 over 3 months. So that's our slope. Now we can use this as our unit rate, so it wants to know each month. So essentially it wants the unit rate, and that simplifies to $45 per month. For part B, it says determine how much money Shirin will have saved after 10 months. So what we can do is we can use that ratio to be able to get to 10 months. So I can go from 5 to 10, so that's going to be plus 5 months. And using that ratio, for every month is $45, so for 5 months that works out to be plus $225. Okay, so we're going to end up with adding $225 to $280, and that gives us $505. So after 10 months, he's going to have saved $505. So that's at 10 months. So we could use a table to do this. We could also come up with the equation for this. So I'm going to come up with the equation for this relationship. For the equation, I need y equals mx plus b. So the y is going to be the balance. The m is our slope. So I'm going to use the slope that we calculated, which is $45 per month, times the month saved. So we'll just make that m, plus the starting amount. Well, the starting amount's not given in the problem, but we could use our rate in the problem to get back to 0. So one way to do it is I can go minus 2 months, and I'm going to go minus $90. And that gives me back to a starting position of $55 at the very beginning. So that's going to give us plus 55 here. Now there's other ways we can solve for that last point, for the starting point. Okay, so although I figured this out already, I'm going to do it again a different way. So an alternative way would be to do this. We have y equals 45x plus b, and a generalization we can always make is that every x and y coordinate must fit into the x and y in the equation. They have to. Okay, that's always true. So what I can do is I can replace y with $145, because we know for y is $145, that's when we're at 2 months. And then we could solve for b algebraically. So I end up with 145 is equal to 90 plus b. Subtract 90 from both sides, and I get b is equal to $55. So this is an alternative way to solve for b. Okay, and this is more of an algebraic method, and this is probably a fairly efficient way to do it rather than counting back on the table like I did in the green. In either case, once I find the equation, I can find the balance at 10 months. Okay, sorry, it tells me I want to find the balance at 10 months. So B, the balance when months is 10 is equal to $45 times 10 months plus the original $55, and that gives me 450 plus 55, which gives me the answer of $505. Okay, and it happens at 10 months. Okay, so that's another way I could do this. I could have, the first way I counted in the table using the differences, the ratio of change. A second way was to solve for the equation and actually plug in 10 for the months in the equation. So part C says, determine how much money Sharon had in his account when he started saving his money. Well, that was, C was the starting amount of $55. Okay? And what assumptions did you make when you answered parts A to C? Well, we make an assumption that this is a linear equation. So the assumption this is a linear relationship.